All right, everyone. We're just letting a few more people in from the waiting room. So we'll just give a couple more seconds here just so I can get everybody in. But while we're doing that, if you guys want to turn your camera on, we would love to pretend like we're all together and see your faces since you can see all of us. That would be amazing. If you're shy, I understand. No judgment. Oh, thanks. Wave. All right, looks like we got a pretty good turnout here. Well, I'll let some people in as they show up, but with that, let's get started. So thank you all for joining. I am Abby Delaney. I am the marketing manager with BigRep. And like I mentioned, I really wish that we were all together, preferably someplace nice and tropical, but if not, this will do. In the place of some trade shows. But we've got a great agenda for you guys today. I've got Frank and June from Selway, our newest partner out on the West Coast there. And Frank is in Boston. Chris will be joining us. He's in where you can see the BigRep 1 there. He's in Boston, so he's going to be doing the demo. And then Maggie, if she gives a little wave, she's in New York, and she's going to be doing our software demo. So we're scattered all over the States tonight, and we're very happy to be with you all. Just a few housekeeping things before I stop talking. If you look in your upper right corner is mine. We're probably viewing us all in a Brady Bunch view, as I call it. You can change to speaker view, so you'll just see one main speaker large on your screen. It's very helpful. If you don't want to do it now, it's fine. But when you get to Chris's part, it's very helpful so you can actually see up close what he's doing. And he is live, so if anything happens, it's happening in real time. Next thing, if you have any questions at any time, feel free to chat those to me directly. So all you have to do is hit the chat button on the bottom, and that will pop up and you can text us any questions. When Chris is giving his demos, we'll pause after each one. So he'll go from the 1 to the Pro to the G2, and after each one, we'll have an opportunity to ask him questions as well. So don't hold back, and if you are ambitious, feel free to raise your hand. You can do that by clicking the More next to your name in the participant list. I'll see your hand raised, and then I can call on you so you can interact with us live. We're going to really try to pretend like we're all together in the same room. So with that, I think we will turn it over to Frank.
Well, thank you, Abby, and welcome everybody. We wish we could see you at a trade show at one of our offices, but we're hoping this could fill the void until we can get together. We don't want to waste too much time on chatting, so just wanted to give you a little bit about BigRep and Selway. So I'll start, June, I'll start with BigRep, and then you can take over on Selway and why we're a good match for each other. BigRep founded in 2014. It's a Berlin-based company, so we're proud to be good, solid German engineering that actually is really important when you try to create a level bed that's 1 meter square and try to print a part that could be 1 meter high and without getting a millimeter off in any kind of dimension during that print. Many of our competitors can't do that. That's good German engineering. We are the leaders in large format thermoplastic extrusion systems. That's all we do. Our little guy that Chris will show you, the G2, is 1 meter by 1/2 meter by 1/2 meter. But our everyday system and our flagship is the BigRep 1 that you see there in the back of the picture on the right. No problem, I'm not. Is 1 meter cubed. The one was introduced in 2014, been through a few iterations, and Chris will go through some of those features. But we have more than 300 of those BigRep 1s out there and more than 500 systems throughout the marketplace. So we are clearly the leader in large format thermoplastic extrusion systems. And from the start, we've been a global company. So from 2014, the company said we want to have a footprint in North America, and we want to be in Asia as well. So our current North America office is in the Boston area, and if you knew the Boston area, then it would be more specifically Wilmington, Massachusetts, just North Shore of Boston. That's where Chris and Amnon are today. And our Asia office is in Singapore, and Berlin is our European headquarters and our Europe office as well. We have so many Fortune 100 companies in the 500 customers. So if there is a challenge and a problem, we've probably seen it. We do prototyping, tooling, jigs, fixtures, end-use parts. And with that, I'm going to turn it over to you, June, and give us a little update on Selway.
Everybody, I'm June Charisma. I'm the technical sales rep for software and 3D printing / additive manufacturing at Selway. Just a little bit of background on Selway. It started in 1963. In the early and mid 1970s, we became a distributor for American machine tool builders like Excello, American Carlton, Wells Index, and Bandit Controls. Around 1988, we became the exclusive reseller for Northern California, Northern Nevada, Oregon, and Washington for Haas. Now we have local sales and service showrooms in Auburn, Washington, Wilsonville, Oregon, Sacramento, California, Union City, and which is where our corporate office is and where I'm based out of, and Buena Park, California. So, and we've just recently again signed on with BigRep as of the beginning of this year to distribute their large format 3D printers.
Yeah, and it's very exciting for us, June, and that we see that your customer base, those that are doing CNC, those that might be doing injection molding, and might want to, if we can share with them the opportunities and the benefits of having additive as a tool to supplement, augment those other technologies. We're excited to have your customers and your high-end CNC customers on board with us to see where we can take that. We have several companies that do have a lot of CNC machines and have found that additive is a big help, and we'd love to continue to share it with your customers.
Absolutely, and that's what we're here to do. I, again, appreciate the time that you guys have spent on getting this set up to begin to put the word out about BigRep.
Yeah, Abby, before we move on to the demo, and I do want to get to this is all about the demo, but I forgot to mention one thing, that in our Boston office, we are fully packed with the support services that that Selway team would need. So your first call would be to Selway, and then we're here, the team that you see, which is Amnon, Chris, and you'll talk to Maggie a little bit later, are here for those escalation problems. But on top of that, we have a full storage facility of systems, materials, spare parts. So everything that you would buy from BigRep will come out of the Boston office, and you will buy it from the US subsidiary. So you don't have to deal with importing everything from Germany. We do that both from the import and for the lead time. Everything comes out of Boston.
All right, great guys. So while Chris is getting set up, Chris, this is your 10-second warning to when we're going to go live to you in Boston. I'm just going to launch a quick poll. So just to keep this interactive as if we were together, just curious, are you guys currently 3D printing within your organization? So just go ahead and take a quick second, and we'd love for you to answer that question. It'll just give Chris a little direction to know what you guys are all up to. It's looking pretty positive for everyone doing some printing. We have give them one more second here. All right, so we've got about, I'll just share the results quickly here, but it's about 82% are already currently 3D printing, which is great. 1 plans to start soon, and 2 have no plans. Well, my goal here and Chris's goal is to try and convince you, and June's mission in life, to try and convince you to add 3D printing to your arsenal of tools. But with that, Chris, are you there?
Yeah, I'm here.
All right, great. It's all yours.
All right, thank you, Abby. Thank you, Frank and June, for the introduction. My name is Chris Lee. I am an application engineer / technician for BigRep. I am accompanied by Amnon Mami, the guy behind the camera. He is our customer service manager. The office that we're here at houses pretty much our service center. We have about 10 machines. They do anything from benchmark parts to print services. The one we have here is our flagship machine. As Frank mentioned earlier, about 500 machines, 300 of them are the BigRep 1. The BigRep 1 has been around for about 6 years. It's been our claim to fame. It's been our workhorse. This is our 3rd iteration of the BigRep 1. We call it the BigRep 1 due to its build size of 1 meter cubed, or roughly 40 inches X, Y, and Z. All manufactured, distributed out of Berlin, Germany. We trust our German engineering. We, print these guys 24/7, 365. It can go anywhere from offices to schools, universities, to high-end manufacturing facilities. It all depends on the end-use application, and the one has the versatility as well as the consistency to be able to withstand whatever is thrown towards it. So right away you can tell, outside of the large volume, there are 2 extruders, meaning we have dual extrusion capability. They are retracting heads in that both of them will not be printing at the same time, but one will be raised or lowered in the Z so that they can switch off during the prints. So the part we have here is just a very large dual extrusion print. The black material is our TPU called Proflex, rubber-like, similar to like a car tire. And then with dual extrusion, we offer the capability of running either a soluble support, a different color of the same material, or a stronger material for just added benefits. So in our case, the gray material is our non-toxic ABS called ProHT, similar to what I have here, just strong, durable, very versatile. The gantry and the motion is belt driven, controlled by nanotech stepper motors. The bed is 1/4-inch aluminum with a layer of polyamide, or we call Kapton film. So the Kapton film is used for material adhesion for that first layer, as well as spreading out the temperature so everything is printing well and you're not going to have any warpage or shifting of the parts as you get higher and higher in the Z. So let's see. So Emma, if you want to take us around the back, we can take a look at the types of materials that we're running. So BigRep, we found our niche in large format FDM polymer or plastic printing. So no pellets, no powders, and no metals. So you can see here we have 2.85 millimeter filament. The filament spools range anywhere from 2.5 kilograms to 8 kilograms, or at least that's what BigRep sells. BigRep does offer an open material platform. So if you want to run our materials, it's very easy. Plug in your files, press go, the machine knows what it's doing. Or if you want to use a third-party material or a new material that we haven't certified yet, the machine doesn't care. We trust our engineering. We trust the throughput of the machine to be able to withstand whatever the customer wants to run through it. So that's something we definitely pride ourselves on. What Amnon is showing here is just the user panel. This is where you would load up jobs. This is where you would run through all of your temperatures, your calibration, things like that. Very easy, very straightforward in terms of usability. Maintenance is pretty minimal outside of the initial calibration during installation. As long as you're keeping the gantry and the bed clean of any dust or leftover particles, as well as keeping the spindles in the Z well greased, not much to do. And then some other added bonuses, if you have the BigRep One on Ethernet connection, that allows for online file upload. And then we also have a couple added features like camera, remote monitoring, and things like that. I think that's it for the one. At this point, I'll take any questions, anything that I may have missed so far.
Yeah, we've got a couple questions that have come in. Yeah. The first one is about the semi-automatic bed level feature. Can you explain that?
Sure. So I don't know if you actually want to take a closer look at our sensor on the left here. So what we have is an inductive sensor. In short, it's a proximity sensor. What that does is go around the outer edges of the bed. I believe it's 8 separate points. At each point, you will get a certain reading. Our tolerance for that reading is about plus or minus 0.02 millimeters. So we would get each point all across the bed to within that range, so that by a couple iterations of going around the bed, takes the technician maybe 15, 20 minutes. The bed will be perfectly level. We do this twice during installation. After that, I don't check it for at least another month or so unless you're seeing some quality issues, which is very, very rare. So very easy, very reliable. Again, what you're looking for in a workhorse in the one.
All right, another question we've got. Is there any influence on ambient room temperature with the printer?
So for your generic stuff like PLA and Pro HT, working temperature is anywhere from 40, 50 degrees Fahrenheit upwards of 90 to 100. Obviously, if you're in the dead of summer in Arizona, you may see a very small change in the way the material is printed. If you're looking at materials like a PVA or TPU, you actually saw before when Amnon went behind the machine, there was a dry box around one of the spools. So we do some pre-processing or pre-drying of the material before it's run, just to alleviate any of those temperature or humidity issues that may come about in certain facilities.
All right, good. Got a couple more coming in here. How difficult is removal from the build plate?
Yep. So part removal, it is material dependent, similar to the temperature humidity. So for example, TPU, it does like to stick a little bit to the bed, but when you cool the bed from 60 C all the way down to room temperature, that thermal process does release the part. I know some customers, they like using 3D printing adhesives that we provide. They are water soluble. So if you use a spray bottle around the edge of the part, that water will soak in and then remove any of the leftover adhesive and create a easy removal of the part.
Great. And BigRep, big parts. One of the questions came in is how easy is it to swap materials if you have to do it during a build?
Yeah, so there are a couple different locations on the printer where we have out of filament sensors. So there is one in the extruder and there's also one above the filament chambers. So it's a physical switch. When it is detecting no filament, it will give a pause sequence to the printer. So wherever the head may be, once it recognizes that command, it will pause, turn off the nozzle temperatures, raise a little bit from the bed, and then give the instructions for the user to reload material, turn the nozzles back on, and then resume. And then it'll resume from wherever it previously stopped. So actually, one thing I forgot to mention with the nozzles. So the nozzles can get upwards of 300 C, and then with the BigRep 1 and its third iteration, we have come up with power extruders, which have the ability to change out nozzle sizes anywhere from 0.6 millimeters all the way up to 2.0 millimeters. So depending on the types of parts that you're running, something like this that has a bit of a tread, or maybe a simpler geometry, you can add on different hardware to go either low and slow for very good looking parts, or run the 2.0 for faster throughput. They won't look as good, but depending on the application, you may not need it.
All right, looks like that's all the questions on the one.
All right.
We'll move on to the Pro.
Yes. All right. So the Pro is kind of like our upgraded version of the one. Clearly, it has the full enclosure. With that, we can run higher grade engineering materials. So in addition to the enclosure, there are two main features that I think separate the Pro from a lot of the other standard industrial 3D printers. One is the new type of extrusion technology that BigRep has developed. We call it MXT. And then the gantry and the control systems. We have partnered with Bosch Rexroth to incorporate their components, their electrical components, into our printer so that we can track a lot of data, run it really fast, and have the consistency and throughput that you're looking for in a high-end machine such as this. So if I open up the door, and I can get a nice little view of the inside. So this part here, finished, I believe, either this morning or last night. It is in our Pro HT. So on the upper right-hand side, you can see the two extruders. I know I mentioned MXT. We also offer an extruder called ACE, very similar to the BigRep 1 extruders. It just goes a little bit faster because it has a little bit more upgrades. So MXT versus ACE. MXT, let me take a step back. So the limiting factor in terms of speed for FDM printing is the thermal process. So you bring in your filament, you have it heat up, constantly waiting until you can continue to move on with your print. With MXT, we now have a small pool of pre-melted material so that you're no longer waiting for that filament to melt. You will always have something to push out, to extrude. So now our limiting factor is actually how fast we can move the gantry with the new CNC control system. So the MXT right now for materials is with nylon, with more engineering grade materials to come. The ACE serves as a support extruder, and then all the other standard materials that we offer. In terms of setup, we offer dual ACE, dual MXT. The ACE will have the range of nozzle sizes like the 1, so 0.6, 1.0, and 2.0. And the MXT right now will have 1 with the other sizes soon to come. Because we're dealing with mid-grade engineering materials now with the Pro, we added a couple more ease of use features when dealing with material. We have the heated filament chambers on the left-hand side and the right-hand side. Again, just to dry out your nylons, your ASAs, just to make sure that there's no more moisture within the filament and you're not going to experience any clogging or quality issues as you're printing. All right, and then just a quick little peek into the electronics, just to show you the scale of what we're working with and how much we appreciate what we got from Bosch Rexroth. So something like this, you can see it's a very high-end piece of machinery. At this point, we're just getting our feet wet with what we can do and the amount of data we can store from our prints. At this point, if you're running the Pro with the speed and the throughput, you're printing end-use parts, inline manufacturing, and we can gather the data to gather what's in spec, out of spec, determining your spec, everything that you would need to print high volume parts, large parts, very consistently and at a high quality. And then similar to the one, once you get it on Ethernet or internet connection, you can have the onboard camera, you can do your file upload remotely, all of your standard features there. And then the control panel, the user panel, this is actually Windows-based. The BigRep 1 and the G2 are Linux-based. Windows, just a little bit easier for us to incorporate the Bosch Rexroth, and similar setup to the BigRep 1, very easy, very intuitive control panel and usability.
All right,
any questions regarding the Pro?
Oh, we've got some. A few more are coming in. The first one is, how big is the actual unit?
So actual square footage, it's about 6.5 feet wide by 8 feet long, and about, so I'm 6 foot, so it's maybe a little under that for the height.
Can you give a comparison of a printing time from the 1 versus the Pro?
Yep. So the BigRep 1 already is about 1.1 to 1.2 times as fast as your other leading FDM printers. Stepping from the 1 to the Pro and the MXT, it's about 2 to 3 times as fast. And like I said earlier, we're just getting our feet wet with the CNC control system and really maximizing that. At this point, pretty soon we'll be upwards of 3 to 5 times as fast with a whole range of materials. So to put some of the scale into perspective, this chair here on the BigRep 1 took about, I want to say 30 hours. This is in our Pro HT, probably 5 to 8% infill. If this was printed on the Pro with MXT, it'll take about 12 to 15 hours.
Pretty big time savings there. One more question. Does the Pro print in ABS?
Yes. Either in the MXT or base.
Great. Does anyone else have any other questions on the Pro? Oh, sorry, one more coming in. What is the power requirement for the Pro? And I guess while you're at it, maybe backtrack to the 1 and what's the power requirement for that as well?
So I'll start with the 1. The 1 is 208 to 240 volts, 20 amp. And then the Pro, because it's a little bit higher end, it's about 400 volts and then a 30 amp plug.
We've had a couple questions on the slicing software. So just a quick note there. So Maggie is also on the call and she's going to actually give a demo of the slicing software. So I'm not ignoring your questions. So just stay tuned for that demo after Chris is done. But it looks like we're good for the Pro. So now we are going to move on to the baby of the BigRep family.
Okay, great. Yeah, baby is definitely a matter of perspective here. This is still very large, a print size of 1 meter long by a ½ meter wide and a ½ meter tall. It's kind of like a mini Pro, if you would. The G2 is actually the 2nd generation of the Studio. We have the original Studio G1 on the left here. Open environment, closed environment. So the same range of materials that you would have for the Pro, we offer on the Studio G2. And then similar to the Pro, we have heated filament chambers on the bottom. And then ambient heat from the bed can get the print chamber anywhere from 50 to 60 C, depending on the material that you're running. If you need it a little bit cooler, there are fans in the back to expel any leftover heat. So taking a look inside, there is a single extruder on the G2, but there are still 2 heads, 2 nozzles on the inside. So you will get the same dual extrusion like the Pro and the 1. The Studio G2 offers hardened steel nozzles. So similar technology to the BigRep 1, just with the upgraded hardened steel nozzle. So you can use the carbon filled, the glass filled, all the materials that would normally ruin more standard buttons. And then like the 1 and the Pro, we have the camera, the belt-driven gantry, all of the fun stuff that allows us to run 24/7, 365 for whatever you want to put through it.
Chris, what kind of nozzle does the G2 have and what is the biggest nozzle size it can run?
Yeah, so by default, the hardened steel nozzles on the G2 are 0.6 millimeters. We found with the print size and the types of prints that customers were running initially, 0.6 was a good starting point. We do have customers swap out their own nozzles. We don't sell anything outside of the 0.6 by nature, but with the way we run our materials, the way we run our slicing software, all that stuff, it is pretty hackable in terms of software and hardware. So we have customers running 1 mil nozzles, 1.2 mil nozzles, whatever they like.
Great. Temperature ranges for the base and chamber.
Yep. So The filament chambers, where you're heating the material, those get upwards of, I believe it's 50 C. The bed is upwards of 100 C. And like I mentioned, the ambient heat from that bed can get the print chamber, to 50 or 60 C. And then the nozzles, where you're printing out the material, they are upwards of 300 C.
Any other questions? We've got looks like maybe a few more coming in. Chris, do you have any parts handy right there that were printed on the G2 that you could give a time estimate on? Not to put you on the spot because I didn't tell you that, but maybe Amnon can
something behind you. Let me
walk over there.
take a quick little peek at our wall of parts.
And while he's looking for that, Maggie, I'll give your little cue to get ready to go as well.
All right, so just grabbed a couple from what we had available. So with the 0.6 nozzles, obviously the throughput compared to the 1, like if you're using a 1.0 nozzle or a 2.0 nozzle, is a little bit lower, but with that you have the improved resolution and overall finish. So something like this, even though it's a 0.6, it still takes just a few hours. Something like this, probably about maybe 5-6 hours time. And then something like this is about 4 hours time, just due to the geometries. So, and I can give you the close-up view.
You could be a hand
So
model.
for resolutions, so we have the 0.6 nozzle all the way up to the 2.0 nozzle. With that, our layer heights can be anywhere from 100 microns or 0.1 millimeters all the way up to 1.2 millimeters. So like I said, either low and slow or fast and a little bit rough.
All right, great. All right, so while Maggie's getting set up, Chris, what's the biggest part you've printed and what's your favorite part?
Yeah, the biggest part took about a month on the BigRep one. It was just a giant mold that took up the full print volume, X, Y, and Z. One part that comes to mind that I thought was pretty unique was a company. They were doing really complex fiberglass piping. So what they ended up doing, because they couldn't find a really good fiberglass filament, they printed the entire part in PVA, which is a water-soluble support. And then once that part was done, they wrapped the PVA in fiberglass. And then because of the water solubility, they just dunked PVA, had that dissolve, and they just had their fiberglass piping. So that was a pretty unique application and use of 3D printing that I thought was pretty cool.
Great. And if our printer can run for a month, that should show some good quality German engineering there. All right. Thanks, Chris.
Awesome. My pleasure.
I think Maggie is all set and ready. So let's turn it over to her. And then you guys, we had several questions on the slicing software. So it's all you.
Okay. Hi, I'm Maggie Cumming. I'm here over in Brooklyn, New York. I'm just going to do a very brief showcase of Blade, our somewhat recently released in-house slicing software. We have been working with third-party softwares for a long time, but essentially what we wanted to do was provide our clients with a slicing software that was made in-house, that was specific for large format printing and specific for BigRep machines. One of the most helpful bits about our software, or something that we pride ourselves on, is that it does allow for really high optimization for printing parts. So in terms of lowering print time and lowering material usage. As you can see here, I'm looking at the BigRep Studio G2, the machine that Chris just finished showing you. And in there I have a small sample part that's a basic manifold, about medium in size. I have already sliced it, but I'll just quickly go through sort of the look of the slicing software. If you've used Cura before, you might find some of the look similar. So over here you have all your options for all the different machines that you can use. then you have your dual extruder options. And under here is where you'll actually find all of the material options that we provide. And the great part is that since this is an in-house software and it's been worked on not only with our software team, but R&D and our material team, we do have presets for all of our nozzle sizes and all of our materials on all of our machines. So it gives you sort of the availability if you aren't super familiar with 3D printing, getting a really good G-code and a really good printed part, while also providing, as you can see over here to the right, tons of different options so that if you are really familiar with 3D printing and slicing, you can kind of go in there and tweak things according to what you want to achieve. The last bit I will show, I'm going to go to the preview mode here. So essentially this shows you a preview of what to expect. As you can see, you can kind of go down, look inside of your part, see how it will get built up. There are various modes of viewing the part. Right now, as you can see up here, I have it in layer view and line type. So all the different colors mean different elements of the print, such as red for outer line, blue for support material, yellow for top surface. And then you can see in the bottom right-hand corner is where the output of time and material is. So it gives you a really precise estimate as the time of what your print will take. And then it tells you under here the amount of material it'll take. And then if you hover over this little eye, it breaks it down even further for you. So if you are doing dual extrusion printing, it'll break it down as to which amount of material or the amount of material you use for both of the different hot ends, as well as the time it takes to create your infill versus your outer wall versus the skin of your part. So it really gives you a lot of options in terms, like I mentioned before, of optimizing your model. And then as Chris mentioned in his demo, if you do hit save to file here, if your machine is connected to the internet via Ethernet, you can upload it directly from your computer, the G-code output. Or if that is not a possibility for you, you can just easily save it on a USB and upload it manually to the machine. Other questions from before? New questions?
Yep, just do you have to use Blade?
You don't have to use it for the Studio or the One. You do have to use it for the Pro machine, as the Pro includes a new sort of technology with the MXT extruder. But in terms of our other machines, you are able to use other third-party software.
Okay. Any other questions for Maggie on Blade? I think we're good. All right, great. Thanks, Maggie. Thanks, Chris. So before I turn it back over to Frank and June, we are just going to do another quick poll to make sure everybody's still with us, and again, pretend we're together. So this one's just regarding applications. So Frank and June are going to talk some application specific and some case studies. So we're just curious what applications you are currently printing. Prototyping, tooling, patterns, end-use parts. Everybody's printing everything so far. This is great. Results are coming in. I will share them in just a few minutes. Not minutes, seconds. I'm sorry there. All right, great. Let's share these results. All right, so the most is prototyping, 92%. Not surprising there, Frank, but the second one, Frank, there is end-use parts at 67%. That's very interesting. And I'm sure you guys can share some insights and case studies on that. So Frank, I am going to stop sharing this, and the floor is yours. You're muted, Frank. Sorry. You know, for those of you on the West Coast, it's late for us here. It's almost 7 o'clock. We've had a long day, but we're hanging with you.
I wanted to be muted, so I didn't come up, and I forgot. So embarrassing. But great job. I hope everybody got a little bit knowledge of the BigRep systems that we weren't able to show you in person at one of the events or in our office. I think it's really interesting, the poll of expansion into end-use parts, and I think it's inspiring for this industry and to see where it's going to go. I mean, we've been talking about end-use parts, but BigRep actually has many customers now using it for end-use parts, and I think the current pandemic that actually hurt a lot of the supply chain really opened up the pains of having reliance on foreign countries. Now, it's quite clear for many reasons of big molds that were made in Asia to save money. First, they might cost $500,000, but they also take 12, 16 weeks to deliver. And then when you're done, you are stuck with that design. And you guys know that better than I do, you that are doing injection molding. So we have several customers doing really end-use parts, making covers instead of using big injection molds. And you can read about the case study of Yamada that's making a water scooter, and they gave up. They said, no, we're not even going to end-use parts, so to injection molding. We're just using the BigRep printers, and they have, I think, 4 of them by now, just to make the covers for their, for the water scooters. And what we did is we have an engineering solutions team, consulting team that helps them with designing for additive. So if you're interested in getting into something that really you're pushing the edge of your knowledge, call Selway, call BigRep. We'll be there for you to help you design for additive. The Yamada case is amazing how they designed it for strength, for support removal, support reduction, and for their end use. And it gets pretty abused in the water, and they found all their tests that the BigRep parts withstand that. One more second, June, and then let's get going. I wanted to talk about the Boyce case because it's very similar to your customers. So Boyce is in Long Island City, New York, not so far from where Maggie is today, and she supports them there often. And they were a purely CNC aluminum house for years and years and years. That's how they built their success on. And the owner, Charles Boyce, said, I don't need 3D printing. If I can't mill it out of aluminum, I don't need it. And but he did have an expert, a nerd. He brought in a guy that said, no, you're wrong. We need to have one of these things. And they brought in a BigRep studio, and they found that they could do prototypes much quicker with the 3D printer. And then what became really interesting is they tested those parts, and they found that they were strong enough, good enough temperature withstanding, that they could use those for end-use parts. And this is the Boyce case study that you can see on our website, and where really it's put into their end-use parts, and Charles, the owner, talks about now not being able to live without it. And that's really, really interesting. And June, if you think about how many of your customers using many CNC machines that say, oh, I don't need additive, I don't need 3D printing, maybe we can introduce this to them, and they can also jump on like Charles Boyce did.
Yeah, absolutely. And really, I think a lot of questions that I get when I'm out in the field or when I'm talking to people out there about and introducing 3D printing is, when does it make sense to start 3D printing? That's really one of the big questions that I get. So Frank, when does it make sense to start 3D printing?
I find if somebody had a 3D printer, that they would use it. Justify it for one application, find one use. Maybe you're subcontracting to a third party. You'll find that actually it only takes a few large parts to pay for the machine. But when you bring it in-house for that application, then you'll find a dozen other reasons to use the printer. It reminds me of the Ford case study, which is also, I think, relevant for your customers. They're using it for jigs and fixtures. They bought a BigRep 1, ran out of capacity, ended up buying a Pro, and now using both of those machines. They ran out of capacity on the one because they ended up using it for much more than just jigs and fixtures. Everybody in the plant came up and said, oh, I have this problem. Can you customize a part for me here? Can you customize a part for me here? So that was really interesting. And I think that, find an application. a large 3D printer is just another tool in your toolbox. So you want to have, a milling, maybe you want to have vacuum forming, maybe you want to have, all kinds of other smaller tools, cutters, mills, all of these things that you would want in your shop. Additive adds a lot of benefit, especially for thin parts, vents, tubes, all kinds of parts that can't be milled. Today, a lot of people are doing generative design, so they're making it lighter and stronger. That chair that Chris was holding up, it's a really organic shape that you can't make with a CNC machine, can withstand 1,000 pounds of pressure on it. So there's so many opportunities, and again, we have an engineering team that can help you. So if the customer doesn't have the expertise, and that's usually the case, especially with tooling. In the Ford case, it wasn't, but in a lot of companies, they don't know how to handle the CAD. So they want to make jigs and fixtures, but they don't know how to handle the CAD. We actually created a configurator to take an STL file and make it into a jig or a fixture without having to have the 3D CAD file. Just thinking about the customer's needs rather than just selling a machine is really where we want to head.
Excellent. So the other thing that, there's a couple of other large format 3D printing companies out there. My curiosity has always been, what separates you guys from them? How does that, or what do you feel separates BigRep products from the competition?
Yeah, thanks, June. And actually, I think we do separate ourselves, and it's clear we are the leader in large format thermoplastic 3D printing. So certainly the customers have proven that. But it goes to the old saying that sometimes when you buy a cheap alternative, you actually get nothing, and you're better off buying the more expensive, but the better solution that lasts for longer periods of time. And there's a lot of engineering that goes into making a large format printer, trying to get the bed on the same plane when it heats sometimes up to 100 degrees C. So that definitely wants to warp as it cools down. So the design of that, and then keeping the portal, the X and the Y, the Z, coplanar with that, within 1 millimeter is a engineering feat that others fail at. So if you can't print, Chris was talking about printing for sometimes weeks at a time. Usually our prints are 3 to 5 days, maybe 10 days on a big one, but that's a long time, and every second of that time needs to be done correctly or reliably. So you want to be able to push the button and have it print. And I think that's what you get with a BigRep printer. And we've had many of our customers throw away or give to universities, our competitors, because they couldn't rely on it. You get 3 days into a print, you don't want it to fail. Your life, your design, your commitment to your management's on the line. You want to make sure it's working. You can't make up that time. Little things like Chris showed you, the autofilament sensor, being able to restart a job if there's a power outage. These little things, besides the reliability of the system. I don't know if you saw it, but on the printers, there's 4 lead screws and 4 guides on the bigger printers. So that is 8 different guides, lead screws and guides that make sure that the portal that's lifting up is coplanar with the bed. Just little things along the way. But it's the 500 printers and 500 customers that we have that really can make you feel comfortable that you're buying a reliable printer.
Yeah, those are the questions that I had. Frank, if you want to expand some more, or Abby?
Yeah, let me just jump in. Because I think there is sometimes a misconception of why would I need a large 3D printer? And it's not because you need to print 1 meter cubed parts. Most of our customers don't print 1 meter cubed parts. They may print some large parts, and when they print a large part, versus an alternative, they don't want to cut it up in data in CAD and then print it in pieces and then pin and glue it back together. First off, it's time consuming, but second, you don't get the mechanical properties when you're done. So you limit your entire part. I mean, that's one thing that Steelcase said when they were creating their case study with us, is that they used to use desktop printers, and then they found that they just weren't getting good mechanical properties out of the parts that they would make. And now they implemented BigRep, and they designed better furniture. And Steelcase is the largest industrial furniture company in the world. They designed better industrial furniture because they used the BigRep printer, and they implemented BigRep across the world in all their design centers. So that's one thing on why large is just printing it the way you want it. And the other thing is that you might have one particular dimension that you want either stronger or you want finer details. So when you have the flexibility to lay it down, stand it up, and not worry about the size of your printer, you really have that benefit in the BigRep printers. The last thing is, if you want to print many small pieces, so you could lay up 20, 30, 50 pieces, and we have a lot of examples of companies that are printing volume of smaller pieces. And from a serial standpoint, it's only a little bit faster, but the inefficiency of stopping, taking it off, loading it again, printing, actually makes it 2, 3, 4 times faster in the end. Because you're not going to be there right at the right time. So if you want a production tool, large format printing is the right solution.
I guess that's there's that misconception sometimes that a large format printer doesn't do small parts. What I'm getting from that is that it can do small parts, and you can actually, if you think about it, do it at volume versus one at a time with a small printer. Is that right?
Yeah, absolutely. And we're expanding in our material offerings, and we're expanding in our nozzle offerings. So we will soon. Right now, our smallest nozzle that Chris mentioned was 0.6 millimeter. So you can go down to 0.1 millimeter layer height. But we have plans to come out with a 0.4 millimeter, 0.2 millimeter. We hesitate to tell our customers to use those because each one is a linear expansion of time. So if you're using a 0.5 layer but you don't need the resolution for that, you could actually cut the time in half by using a 1 millimeter layer. So you should have the flexibility, and that's what BigRep gives you, to create the part with the highest resolution you need, but not higher. So that's why we have 2 millimeter nozzles, so you can print 1.4 millimeter layer. So you can go in our printers between 0.1 millimeter layer to 1.4 millimeter layer, giving you the flexibility to really get the right time and resolution ratio. Because when it's a large printer, that time might be beyond your time frame of your project. If it's already going to take 5 days and you just cut the resolution in half, now it's 10 days. So maybe that's beyond your capability. So it's always that balance, and we give you that flexibility. But most of our customers, I'd say, are printing 200-300 millimeter size parts, 12 inches size parts. And actually, I consider the need for large format, June, above 200 millimeters, because that's the typical size of a desktop printer. So anything bigger than the alternative, which is a typical desktop printer, print on the system. The G2 actually is an amazing machine for large and small parts, because it's for a 1 meter by half a meter by half a meter. It's got a pretty small footprint. It rolls into a room. It's really quiet. It can sit next to cubicles and you don't even hear it running. So it can be in an office environment. It can be vented right out if needed. But it prints a large part of 1 meter by half a meter by half a meter. So it can do really everything at a very affordable price. So great machine if you don't need 1 meter cubed.
All right, Frank, we got one more topic that just if you could touch on briefly, since we're nearing the end of our time here. Design for additive. What advice can you give people in terms of that?
Yeah, so it is a science, it is an art, both probably, and we have the expertise in-house in our engineering solutions team. For example, if you have a design and you have a wall thickness that is 2 or 2.5, sorry, non-increments of our nozzle diameters, so the system then struggles to either make it smaller or larger. So if along the way you design it with exactly the right amount of width, so it matches the width of the nozzle, you're now designing for additive. Or if you put your features in the area that you want to describe on the printer, so you would have those best features up, and you can design things with less support or more support. So you can lay it down in a given way, and or change the angle of a feature. So we can print greater than 45, but so if you have a piece that sticks out and you put a 45 support on it in the model, then you don't have to have this big amount of support supporting it along the way. So it matters what flexibility you have in the design, and we will be there to help you. If you want to create an end-use part, we would love to help you along the way with designing for additive. But there is, and we did a recent webinar on designing for additive. So Abby, you can point them in the right direction of that one, so I don't misname that.
Yeah. All right. Well, we've only got a few minutes left, so I'm going to kind of wrap this thing up so we can all get on. But I'd like to thank Chris and Amnon in Boston, and Maggie in New York, and Frank somewhere near Boston, and June out in California. This has been great. I've really felt like we were together, and I hope you all did as well. Like Frank mentioned, we've got our team of experts. So with that, I just want to let you guys know that if you have a part and you're curious, hey, should I make this with additive? Is this a good case to try? Our team is happy to do a part analysis for you for free. So that way you can kind of see what it would take, what material they would recommend, the time of the print, and things like that. So feel free to fire those away. I'll send an email out after this, but you know, we would definitely like to help you. Like Frank said, that's what we're here for, and June and his team as well. June, do you have any final words?
Oh, thank you guys so much again for your time. I appreciate it. And yeah, I'm looking forward to seeing well, hopefully answering some more questions offline even, and working with you guys to hopefully adapt large format 3D printing.
All right, great. So with that, thanks again, and stay safe, stay healthy, and go BigRep, and we'll be in touch soon. Thank you.